morning, students. Today I am going to derive an expression for electric potential at a point due to a dipole. So let us derive the expression. So dipole is our two equal and opposite charges separated by a small distance. So plus q minus q, suppose they are separated by distance of 2a, and let O be the center of this dipole. Then this much will be A and this will be also A. Now suppose we want to find out the electric potential at point P due to this dipole. So let us join this plus q with P and let the vector is R1 vector, and from minus q to point P is R2 vector, and the distance from point O to P is R vector. Next, what is the electric potential at point P? As we know, electric potential at a point is the sum of the potential due to individual charges. So V at point P will be the sum of V due to plus Q, then plus V due to minus Q. So what is the electric potential formula? 1 by 4 pi epsilon naught Q by R. So I will write 1 by 4 pi epsilon naught in place of Q. This is due to plus Q, so I will write Q by, what is the distance between them? It is R1. Then plus V minus Q. V at P due to minus Q will be again 1 by 4 pi epsilon naught. In place of Q, I will write minus Q by, the distance is R2. So 1 by 4 pi epsilon naught, Q will be common, and I can write 1 by R1 minus 1 by R2. So let it be equation 1. So now I will write this equation here. V at P is equals to Q by 4 pi epsilon naught 1 by R1 minus 1 by R2 as my equation 1. Now let us find out what is 1 by R1 and 1 by R2. So for that, what will I do? Let us do a perpendicular from charge Q to the line OP, and again extend this point also, and again do a perpendicular to this line. Suppose this is theta, so this will be also theta. So if this is theta, this will be A cos theta, this much value, and this much value will be A sin theta. Similarly, this adjacent side will be again A cos theta, and this perpendicular will be this one will be A sin theta. So now let us find R1. R1 square. In this right angle triangle, R1 square will be this square plus this square. So this square means A sin theta whole square plus, I am using a Pythagoras theorem, R1 square is equals to this perpendicular square and this base square. So this base will be, since the total value is R and this much value is A cos theta, so this much value will be R minus A cos theta. So I will write R minus A cos theta whole square. Now let us solve this. So this will be A square sin square theta plus R square square plus a square cos square theta minus 2ra cos theta. So here let us combine this. Sin square theta plus cos square theta is equals to 1. So I will write a square. So r square plus a square minus 2ra cos theta. Let it be equation 2. Similarly, let us find out this r2. So r2 square will be, see, in this right angle triangle, the r2 square will be this perpendicular square plus this base square. So perpendicular is a sin theta square plus, what will be the value for base? No, this total is r and this one is a cos theta. So r plus a cos theta, and I can write it as, what will be the value if I will solve this? Obviously this will be r square plus a square plus 2ra cos theta. So let it be equation 3. So I am writing the equation 3 now here as r2 square is equals to r square plus a square plus 2ra cos theta. Okay, after this I will again jump to the equation 2. So let us solve this equation 2. So this is equals to this much. So in the next step, r1 square from equation 2, I will write r1 square is equals to, let us take common r square. Then what will be the value? No, 1 plus a square by r square minus 2a cos theta by r. So this will be the value if I will take common. Next, since the a value, our dipole length is small, then this a value will be small. So I can write that for a much less than r, what will happen? Now this, since a is very small, so the a square term will be also very small and which can be negligible. So this term becomes equals to 0. So now I will write that r square 1 minus 2a cos theta by r. Next, now remove this square, so r1 become r 1 minus 2a cos theta by r to the power half. Now let us take 1 by r1. So if I will do 1 by r1, then this will become also 1 by r, and this half becomes equals to minus half. So 1 minus 2a cos theta by r minus half. Now let us use the binomial expansion expression, that is 1 plus x to the power n is 1 plus nx plus your higher order of x power. So since our a is very small, so the next expression, if I will use this here, that is 1 minus 2a cos theta by r to the power minus half in this expression. So here a, since higher powers of x, that means here we will also get higher powers of a, again which can be negligible. negligible, then we can go for only this term. So if I will use that one, so I will get that is equals to 1 by r 1 this nx, that means n will come to here, so minus half minus plus half into 2a cos theta by r. So this 2 get cancelled and I will get that 1 by r1 is how much? No, 1 by r1 will be 1 by r1 will be equals to 1 by r 1 plus a cos theta by r. So let it be equation 4. So as we have derived for the 1 by r1, similarly we can also derive 1 by r2 using the equation 3, r2 square this much. So if we will solve this one, we will get, we can write it as similarly 1 by r2 will be equals to 1 by r and 1 minus a cos theta by r. Now let us use these two equations. Let it be equation 5. Now let us use these two equations in equation 1. So putting the values of 4 and 5 in equation 1, we will have V at point P is Q by 4 pi epsilon naught 1 by R1. So 1 by R. See here we can take common 1 by R. So let us take 1 by R common. Then put the value 1 plus a cos theta by R. We are having a minus here. So minus of this value. So minus 1 minus minus plus a cos theta by R. So now this will be cancelled and we are having the expression as Q by 4 pi epsilon naught. This will be your 2a cos theta by R and another R is here. So what will be the value? Now I am getting the last expression. See Q into 2a. We know that the dipole moment is the magnitude of charge into the dipole length. So Q into 2a is P cos theta by 4 pi epsilon naught R square. So now this is the expression for potential at point P due to the dipole, and I can write it again as P vector dot R cap is your P cos theta and the denominator expression like this. P cos theta means here if I will write this dot product P dot R cap, obviously it will give me P R cos theta and R cap is the unit vector along this direction as our theta is this. So P dot R will give you P cos theta. So this is the expression for potential at point P. And if you want to find out what is the potential at axial point, then for axial means the axis will be along this direction or along this direction. So we can have this theta value. This axis becomes like this, or we can say it will be like this. So this theta becomes 0 or 180. So for axial we can write plus or minus cos 0 is our 1. So P by 4 pi epsilon naught r square. That is for theta 0 plus p by 4 pi epsilon naught r square, and for theta 180 I will write this minus p by 4 pi epsilon r square. And what will be the equatorial value? If you are going for equatorial point, that means this theta value, equatorial point theta value becomes 90 degree. So for 90 degree the value will be 0. So this is the expression of potential due to dipole. Go through it and revise this. Next class we will go for equipotential surface. Thank you, students.